This is a mixture problem involving distance. Two cyclists decide to bike the Virginia Creeper Trail, starting at the midpoint of the trail and riding in opposite directions. One cyclist travels at an average of 9 miles per hour, and the other maintains an average speed of 11 miles per hour. If they start at 10 a.m., at what time will they be 50 miles apart? Because this is a distance problem, this is based on the formula D equals RT. The distance equals the rate times the time. We're going to do a problem setup. So we're going to write a distance, a rate, and a time for each rider. Now, we don't know all of these things, of course, but we're going to define them with either a number or a variable. And one thing that really helps with distance problems are pictures. Sometimes a distance picture helps, sometimes a time picture helps. All right, so if I were to draw a picture of what's going on in this problem, then I would pick a starting point for my riders, and one rider rides in this direction at 11 miles per hour. Another rider rides in the opposite direction at 9 miles per hour. The problem says that at some time they will be 50 miles apart. So my 50 miles will be the distance from the end of the one cyclist to the location of the other cyclist. So here's a distance picture that I can use to help me fill in the distances for the different riders. All right, let's look at the 9 mile per hour rider first. Of course, I'll go ahead and put the rates in, 9 and 11. That was easy. Now, when we look at the distances, I don't know what this distance is, and I don't know what this distance is, but I know that they are 50 miles apart. So anything I don't know, I can assign a letter to. Let's call the distance that the 9 mile per hour bike rider travels X. If he travels X miles, and the total distance in my picture is 50 miles, then the other rider must travel 50 minus X. Sometimes a picture helps you to identify exactly what information you do have. Now, as far as the time goes, it says they start at 10 a.m. At what time will they be 50 miles apart? Well, we know they start at the same time, and what's going to happen is, it's like I'm going to take a picture, and all of a sudden when they're 50 miles per hour, I'm going to click the camera, and it will be at the same time for both riders. So they start at the same time, and as far as my problem is concerned, they finish at the same time. So that means they're both traveling for the same amount of time, and we can call that Y because we don't know how long it takes them to ride and get 50 miles apart. Now this is what I call my problem setup. I've set up my information. All I have to do now is write my equations and do my algebra. The equation that describes the first rider's trip is X equals 9Y. And the equation that describes the second rider's trip is 50 minus X equals 11Y. It's just based off of the formula D equals RT. So this rider's D equals his rate times his time, and this rider's D equals his rate times his time. The rest is algebra, and generally with distance mixture problems, you can have two variables. So what I need to do now is put the two equations together using substitution. If X equals 9Y, then it's very easy for me to substitute this into the other equation over here. So I'm going to say 50 minus 9Y instead of X equals 11Y. Now I have one equation with one unknown, and I can solve for that unknown. So I'll add 9Y to both sides. And then I have 50 equals 20Y. I'll divide both sides by 20. And I get that Y equals 5 over 2. Now, Y, remember, is my time. So, since my rates are in miles per hour, and my distances are in miles, my time is in hours. So this is 5 over 2 hours, or Y equals 2 1/2 hours. That means that this rider rides for 2.5 hours, and this rider rides for 2.5 hours. In other words, it takes 2.5 hours for them to get 50 miles apart. But the question doesn't ask how long does it take them. It says at what time will they be 50 miles apart. So if they start at 10 a.m. and they ride for 2.5 hours, then it's 12:30 in the afternoon. So that's 12:30 p.m. when they are finally 50 miles apart. This is what answers the question.